For 7b, you have to solve by elimination. And in order to do that, the first thing that you have to do is line the two equations right up underneath each other. So if this is my equation 1, this is equation 2, I'll bring equation 2 right underneath 1. So 3x minus y equals 4. And the whole point of elimination is to get one of the two variables to eliminate. And the way that you do that is first by getting them to be the same value, and then second, opposite signs. Meaning one is positive and the other is negative. And so if we look back at problem number 1, we can see that we have this situation where our y and in both equations are opposite and the same value, so they cancel out, leaving us to just basically add the rest. And so 2x plus 3x gives us 5x, and then 6 plus 4 is 10. We're not done yet. We have to divide by 5 to get the x alone. And when we do that, we get x equals 2. Now before we're done, we have to, okay, we can fill in this box, but we still have to fill in our y. And the way that we do that, and it's a lot less work, is by plugging in whatever variable we found into the equation, either 1 or 2. So I'm going to use equation 1. So 2x, and what would be 2x, I'll now replace with a 2. So I have 2 times 2 plus y equals 6. That gives me 4. And now I can subtract my 4 off to see that y equals 2. For this check part, one way that you can check is by using one of the two equations. So I'll use this number 2 equation. If this is my x and this is my y, where my x was, I'll fill with a 2. And since they're identical, they both get 2's, equals 4. And so we're going to just see if this is a true statement. So 3 times 2 is 6, minus 2 does equal 4, so that checks out. A more difficult problem, where they don't work out ideally, would be a situation like number 6. So if we look at number 6, I'll first line my equations right underneath each other. So I get my equation number 2 right underneath my first equation, and I start to look for stuff I can cancel. So my x's won't cancel because they're not the same value, and my y's won't cancel because first, they're not even the same value nor the same sign, or they're not altering signs, so it won't work. And what we can do is by multiplying one of the two equations to get a situation that will allow us to cancel. So what we'll do is we'll multiply this top equation by 2, because I'm going to try to get my x's to cancel. So if I multiply my 2x by 2, I'll get a positive 4x, which will fit my criteria. But since I multiplied that 2x by 2, I have to do it to everything within the equation. So I get 2 times 3y is a positive 6y, and 2 times 1 is a positive 2. Now I can treat everything like addition, and stuff will start to cancel. So as intended, our x's will cancel. And now we just add 2y to 6y, giving us 8y. And 2 plus 2 is 4. We can't leave that 8 next to the y, so we'll have to divide it off. So we'll divide both sides by 8. And 4/8 can be reduced down. So how we can think about it is we can take a 4 out of both of these numbers. So if I divide 4 by 4, I get 1. And 8 divided by 4 is 2. So y equals 1/2. The last thing I need to do is solve for x. So I can use one of the two equations again to solve for it by plugging in what we've just found out. So y is 1/2. So I'll plug it into this equation here. So I'll get negative 4x plus, and since it was y that I found, I'll plug in the 2 for the y. And that's all equal to 2. Now, negative 4x gets brought down. 2 times 2 is a positive 4, and that's all equal to 2. So I'll subtract my 4 off. That cancels, and I'll get negative 4x equals a negative 2. Lastly, I'll divide this negative 4 off. And I can do the same thing for reducing my fraction. So negative 2 divided by 2 is a negative 1. And negative 4 divided by 2 is a negative 2. So that cancels, leaving us with a positive 1/2. So for this solution, we get x equaling 1/2 and y equaling 1/2. If we go through this story problem,